Question 15 is the last one in the part 1 and it is about symmetry. Here we have a figure, and is it possible to draw lines of symmetry, and if so, how many? Look at this. It looks like an equilateral triangle, isn't it? So what you do is start drawing lines. Now imagine I will, draw a line vertical like this. Okay, it's not very straight, but if you draw a straight line, whether it'll cut into equal parts, a symmetrical part, whether this line can be a mirror. Yes, because this length and this length will be same, the other two lengths, this length, it'll be same if I draw it exactly from this vertex to the center over here. But even the same thing can be done over here. Now you can see this and this is equal, or if I draw it like this, equal, and like this. So how many lines of symmetry can be possible? Only 3 times it's possible. But whereas if I draw like this is a triangle, this is a trapezoid, no, that's not possible. If I draw it, say, similar to this, no, it should be exactly at the center, okay, middle. Then it's possible. Looking at this figure, we can easily tell it's 3 lines of symmetry, isn't it? 1, 2, 3. The answer is yes, we can draw a line of symmetry, and it's 3. Now what about this one? If I draw, say, like this, is it symmetrical? Now you must realize, see, it looks, okay, this is big length, this is same. Isn't it symmetrical? No, it's not symmetrical. Now if I draw a diagonal like this, look at this length, is it the same over here? Only if this and this is same next to it, then it's correct. No, this is not the same. See, over here we have the long length, and over here we have short length. It's not at all symmetrical. Whereas if I draw it like this, a flat line, now we can see this length is same. Over here this length is same, this is symmetrical. Or if I cut it in the middle, it is equal. You should cut them into 2 equal halves like a mirror. Okay, so now these 2 only lines, not the diagonal. Though it's similar parts, but no, it's not the same side. Left is small length, over here it's big length, not possible. What about this one now? Let us try the diagonal thing. If I draw from here and here, like wherever is the center, is it possible? Imagine that's the center. It's not symmetrical because this is small and this is big. Only for equilateral triangles it's possible. This is no symmetrical line possible here. None. Because no matter where you cut, from here, everywhere, the lengths won't be the same. What about this now? Again, this is a parallelogram. Now we can draw the diagonals, but this length is small, this is big. No, again, no. Try anywhere straight, anywhere, you won't get equal parts. If you're thinking, what about this flat line? From here, no, it should cut like this, or over here. No, you won't get, because this will be smaller length, this will be bigger length. You can see the shape is not the same. If at all it was like this, then yes, you can cut, it'll be equal. But for a parallelogram over here, it's not possible. No. This is yes. Why? Because looking at it only, you can tell if you cut it, now equal parts, same length, everything is same. Now what about like this? That is, no. Wait, let us consider this as the base, and like this is possible. From here, yes, this is possible. So many are possible. How many exactly? Depending on the vertices, 1, 2, 3, 4, 5 vertices. So 5 lines of symmetry. Because from each vertex you can draw. This is the answer. Now don't think, okay, there are over here 10. No, it's 1 line. 2 ends are there. 1, 2, 3, 4, 5. Now what about this? Absolutely. Again, depending on the vertices, how many sides are there? 1, 2, 3, 4, 5, 6, 7, 8. 8 vertices. Yeah. And what about these? Steve found a hubcap shown below in his local junkyard. Determine whether each hubcap has a rotational symmetry. Explain. Now here to have rotational symmetry, what happens is whenever you turn, like by any degrees, by a certain degrees, say you turn this by 90 degrees or 180 degrees. When you turn it, it'll be the same position. If you turn it, it'll be, this will come over here. The points will again turn. It'll be the same thing, right? So weird, since there are 4 points, you can divide a 360 by 4. For every 90 degree, you will get the same shape again and again. So yes, there is a rotational symmetry, you can say. what they want to know is less than 360 degree only, this will come to its same position. Absolutely, because if you turn at 90 degree, it is possible and it will come to the same shape. But what about over here? You just now saw the answer. It's no. Why no? Think about it. Because over here also, if you rotate, it should come, right? If you're thinking why. And over here, it's yes. It'll come with less than 360. 360 means you will do a complete rotation. Now imagine, this is the thing. Over here, if I just turn it a little bit, if I turn it a little bit, it's going to be something like this, isn't it? This is not mapping on itself. But if I rotate it more, 90 degree, it maps on itself again. But imagine there is a shape like this. Why it is not possible? But once you turn it by 360 degree, yes, it will come because you're doing one complete revolution. Look at this over here button. Is it the same? Because this is not same. So since one of the shapes, see, all these are entirely symmetrical, they're all same everywhere. But this one is not same. So if you move, this will be over here. No, that's not possible. Then over here, over here, over here. In order for it to come back, it must be 360 degrees. So there is no way rotation less than 360 is possible because of this, image. You can say because this over here is a different image, unique image. It's not the same. But over here, all are same. All the buttons are same. Even over here, everything is same. With less than 360, you can get the original shape, whatever is there, performed again. So this is the concept. And that's the end of part one. Finally, we have finished all the questions. I wish you all the very best for your exams. Please do study well. Don't keep it at the last minute. Try to revise as early as possible. If you have any doubts, please do post them in the comments and I'll try to get back to you very soon. You can find all the explanation videos of part 1 questions and part 2 questions in my channel. I just want to thank each and every one of you for supporting my channel, for subscribing to my channel, for sharing my videos with your friends. I really appreciate it so much. I'm so grateful to all of you guys for all the support, for all the love. I just want to wish you all the very best. I hope everyone gets great marks in their exams. I wish you good luck and take care.